Hi guys, welcome back to the Astro Imaging channel. Tonight's session is on a Q&A, a short presentation and a Q&A on single board computers for astrophotography, and it's going to be presented by Jasem, who is the developer of K-Stars, Indy, and more recently the Stellarmate single board computer, I believe Raspberry Pi based all-in-one acquisition device. It is basically one of the smallest OTA top acquisition devices that you could buy out there right now, and it has full features for automation. But as always, before we do that, I am going to jump over to our image of the week. If I can find that screen. Why can't I find that screen? There we go. I hope you can see that. This week's image of the week, the Cygnus bubble or the soap bubble by Brendan Kinch. And I've always loved this object. Probably the reason I love this object the most is it was discovered while I was in the hobby, while I was shooting. In fact, it was discovered, and then I went into my data that I had shot right around the same time, and you could see a little bit of it. But somebody out there looked hard in his data and found this, and that just is really cool that amateurs like us can detect new objects. And you guys can shoot it too, a newly discovered object. Definitely worth a try. Very difficult. My successful attempts have been anywhere between 16 and 40 hours, but Brendan did this one, and unfortunately, I don't know how long his exposure time was, but I'm sure he put in the time on this one because it stands out nicely. So thank you, Brendan, for submitting, and you all know you can submit on the website right there. Popping back over. Got it. We do have Jasem in the room. I'm going to hand him the camera. And we did get some questions earlier. He might touch on them at some point. He's trying not to have this be as much of a tech support type presentation as it would be a more of a Q&A about what is involved in using one of these, what they're capable of, just answering kind of the basics so that you know whether it's something to pursue for your astrophotography. But Jasem, you have the camera. And you have the microphone as well.
Okay. Well, thank you, Adam. I'm going to provide a short presentation on single board computer astrophotography. And the question is, are we there yet? Is it ready for prime time? And the spoiler alert, it really depends on you. So let's go ahead and get started. So just a little bit back of history. Single board computers are not really a new thing. They've been here since the 1970s, but mostly like for embedded hardware platform, embedded like in devices used for manufacturing and other industries. One of the first open source SBCs, as they're called, was BeagleBone. It was released 2008. Had limited functionality. Some people might confuse the Arduino as being a single board computer, while it's it's technically as a microcontroller, so it runs the same program over and over again, while a computer in the modern sense can run a full-fledged operating system. And the milestone actually was in 2012 when Raspberry Pi, the first Raspberry Pi model was produced. And Raspberry Pi is like a full-fledged computer, credit card sized computer, around $35, and was mass produced 2012. And it's led to a revolution in using single board computers for all like hobbies and also for industrial use. The first specifications for the Raspberry Pi, one is like a very, compared to the current generation, it's very mediocre. You can see it only has 512 megabytes of RAM, only 2 USB ports. It has a shared 100 megabits Ethernet with the USB bus. Actually, that's, I think, still the case right now. But what's really interesting about this board is it can run a full-fledged operating system. It started with Linux, and then it moved to Windows recently. And this is the OS it was running. This is Raspbian OS, which is a derivation of Debian OS on Linux. This is Stellarmate OS, which is also based on Ubuntu and runs on Raspberry Pi 3. So when we're talking about single-board computers versus the regular computers that we're used to every day, what are some of the pros and cons? So the first pros is single-board computers are pretty cheap. So you can pay like $35 or $50, or maybe really expensive one with $75. And so they're cheap and they're expendable. So if you break one, if you lose one when it's snowing outside, you don't really feel as bad as if you lose your MacBook, for example. So they're expendable and they're cheap, and you can buy more than one to tinker with. Another pro is that they're remote by nature. And this is especially emphasized that the software stack that's running on the current Raspberry Pis, for example, or the SPCs now, they tend to be remote like fully. You don't even need to have a team viewer or VNC to get in there to do things. For astrophotography, I'm talking about. So in astrophotography, you can use them in a fully remote fashion without using any of the known third-party solution like TeamViewer to log in and do your astrophotography. And also they're open source, and so this might be interesting to some people who love open source. Some people are not really interested. They just want something to work. But open source is really good because by sharing the code, you allow other people to modify and extend the functionality of the software and even provide new functionalities. Also, the software stack itself is considered a pro because a lot of the professional level observatories are running like Linux or Unix-like systems, and there is this like large library of software that was developed in the professional observatories that are now available to users on these single-board computer systems. One of them is astrometry.net. To this day, to get astrometry.net under other systems, you really need to have a lot of tricks to get it like running under Windows, but it's native to Linux. So now it's not all roses. Let's go to the cons. So performance. So of course you get what you pay for. So for $35, you're not gonna get the same performance as your quad-core i7 core CPU. So the performance is not as great. You have limitations with the RAM. You have limitation with the bus itself. Many of these ports come with only USB 2.0 ports. So all your new fancy USB 3.0 cameras are not gonna deliver their maximum bandwidth as they could on like a modern PC or a Mac, where you have USB 3.0 and 3.1, and even like upcoming 3.1 generation 2. So the performance, you pay a performance penalty. But the question is, this performance penalty will make astrophotography not work? It actually doesn't. Another issue is reliability. So again, because it's cheap, you're not paying for top reliable parts. And this is something I experienced personally over the last year, where I tried a half dozen single board computers in order to arrive at what is the best one to fit my needs. I have an observatory at home, and I wanted the single board computer to operate it. So I tinkered with many. And one problem I found was the components, like the USB port, the Ethernet port, etc. They're not as reliable. There is a chance it could break up due to heat, especially where I live, and because they're fanless, there are no fans, so they're more susceptible to environmental conditions. And again, the same pro is also the same con. So the library of software that most end users are familiar with, especially under Windows, it's not going to be available under most of these single-board computers operating systems. However, recently with Raspberry Pi 3s and a lot of other single-board computers, you can run Windows 10 on these boards, and so the software issue is not really applicable there anymore. So here's a list of some entry-level single-board computers. The most popular one is probably Raspberry Pi 3, which is what I based Stellarmate on, because it's not the best one in terms of performance, but it's the most reliable. And that was the reason I actually selected Raspberry Pi 3. And these boards, also we have the mid-level boards, so they're more expensive than $75, like the Odoo 86 single board computer. So this runs like an Atom x86 processor. So now you're not limited to ARM architecture. There is a lot of software, especially proprietary software out there, that cannot run on non-x86 architectures. So it cannot run on ARM architecture specifically. It needs either 32-bit system or 64-bit, but it cannot run on ARM. And of course, with all these boards, you have a plethora of distributions to choose from. Most of them are based on Debian, and I think right now the most popular is probably Ubuntu and Debian. These two distributions are like the first selection for newcomers to this industry. But moving on from single board computers, because of the price, I'm talking about these here, mini computers now are getting pretty popular, especially in the last couple of years. So they're not technically single board computers, but they're getting quite cheap. You can get something 2 to 4 GB of RAM, maybe 32 GB of storage, and they really only cost like between $99 to $200 range. And these support both Windows and Linux. And so you can use these instead of the cheaper like Raspberry Pi alternatives if you want to get more performance out of your system. So now let's just talk shortly about the Linux versus Windows boards, because some boards you can only like, or the most solution for it is Linux, while other boards are more designated toward Windows. So for the Linux boards, as far as astrophotography goes, all of them would support ND out of the box. So ND is the protocol that talks and communicates to your devices. It's the Linux equivalent of ASCOM on Windows World. So if you get a Windows board, the problem with ASCOM right now, as we speak, is that it's only limited to x86 processors. So it cannot run on ARM architecture right now, and it probably can do in the future, but currently it's only limited to x86 processors. So ND can run on any SPCs, while the Windows board or the Windows OS usually work on mid to high range single port computers. And also ND supports some legacy cameras that are not supported now in Windows, especially like old DSLR cameras. But there is limited support for hardware because ND is not as supported in the industry as ASCOM is. So there is a lot more hardware support for ASCOM, but the situation under ND and Linux is improving now with time. So now, yeah, the advantage with Windows, of course, is better device support. So if you choose to go with Linux right now on your single port computers, you're looking at something like this. So you can get a stack of ND for the communication protocol. You can then use a client like KSARS, or you can use something like the SkyX. They just recently released the SkyX for Raspberry Pi 3. Or you can use other programs like SkyCharts. On Windows, of course, most people are familiar with the software stack of ASCOM, and then of course all the big names in astrophotography like Maxim DL, the SkyX, SGB, etc. So you have a shorter list on Linux, but the cost is also less on Linux side. So now the question everyone is asking, is it for me? Is single board computers and astrophotography for me? So you have to answer all these questions and see if they're applicable to you. So do you want to reduce costs? If yes, and costs are really important to you, then you should probably go the route of single port computers on Linux because the costs are almost negligible. You can get a fully running system with less than $50. Do you want to carry less gear? So again, if you don't want to get your laptop or with you every time you go out to do astrophotography, then you should probably go single board computer. This is also really important. Do you like to tinker? So for those who love to tinker and explore new boards and discover new operating systems and just love these things, then this is just a natural outcome, is to try new things. And some people are just comfortable with their existing workflow. Like, I don't want to invest any time or money to look into alternative system. So if you're really comfortable and you're not looking to do anything outside of the existing workflow, so maybe this is not suitable solution for you. And finally, because these are like evolving technologies, especially on the single board computer side, it requires some investment of your time. So if you're short on time and you're mostly busy and you can't have time dedicated to like troubleshooting issues and reading manuals and watching videos online, then maybe this is, I guess it ties to the previous one. It is, do you want to change your workflow? So if you don't have time to invest, then this is also not the way to go. So this is a solution is for people who like to tinker, who like to reduce costs, and who have time to look into new technologies. And sorry, I think I took more than I wanted in this slide, and that's pretty much it. So I'm available for any questions right now. Thank you.
Awesome. Thanks, Jasem. It's interesting getting your ideas on it. The thing that pops into my mind, and you say, if you like to tinker, it seems like a technology that, the way you framed it, it's a technology that is on the cusp of making everything a lot simpler.
Right.
We're used to doing it the way we do, and I don't believe astrophotography will ever be easy. But when you have to explain to someone what you do, what goes into taking your images, and you hit the 5-minute mark into trying to explain to them what you do, they all of a sudden go from thinking this is the most interesting thing in the world that they want to try to saying, maybe I can't do that, maybe that's too difficult, maybe that's too expensive. Yeah. I almost look at it as being a product that could, in time, do for astrophotography what the iPad and Facebook did for computers. Because 15 years ago, computers were kind of geeky things that you used at work, and grandmothers weren't using them. My mother wasn't using one. Then Facebook and iPads came out, and it was like every grandmother was on Facebook, and it changed the world. We're just trying to make astrophotography a little bit more available, right?
Exactly.
But, I see a lot of promise in the technology. I'm trying to see whether any new questions had come in. I know you saw those previous ones, which did seem a little more like tech support. Where do you suggest people find their tech support for any issues like what had been posted?
Well, there are two sources. They can either post them in the Indie forum, or if they are owners of Stellarmate, like if they're Stellarmate customers, then they can use the Stellarmate website to submit any questions.
Okay. And so you're saying that basically the biggest hardware limitation, or I should say the biggest limitation in using hardware seemed to be USB 3.0, the lack of USB 3.0. And I don't mean processing speed wise. I don't mean RAM. I don't mean anything like that. Is that am I hitting that or no? Am I correct on that?
I think that's the second thing I would say.
Okay.
The first thing is probably the RAM. Currently now with Raspberry Pi 3, we're limited by just 1 gig of RAM.
Mm-hmm.
And we really have to now do like tricks to make it appear like 2 GB RAM, because some drivers expect to have this much RAM available to them. And so I think RAM is the biggest limitation, but this is hopefully improves with time.
Mm-hmm.
And then, yeah, the bus and CPU then comes after the RAM. But RAM is the biggest obstacle right now.
Okay. Yeah, I'm trying to think because I do not own a USB 3 device, I don't believe. Or maybe my Surface has USB 3, but I don't use it on my acquisition PC. My acquisition PC is probably 15 years old. So it's not something that's really demanding when it comes to that. Maybe plate solving a little bit.
It's mostly important for those who want to do like electronic assisted astronomy, or you want to do like planetary viewing, things like that. Things of this nature would be more demanding on the USB bus.
Right.
In my observatory, I have 2 cameras attached. I'm doing guiding. I'm doing 16 megabit resolution images, and I don't have problems with the USB bus.
Do you have a sense for how much difference image download time would be for a 26 megapixel image USB 2 rather than USB 3? And that's a kind of an aside question.
Okay. Well, is the host device supports USB 2 or 3? I mean, that depends on the host device if it supports a 2 or 3. I think I don't know. I mean, I have to look up the actual calculation for that. That's like a math question, but it's definitely faster. But in the scheme of things, it doesn't really affect your astrophotography session. In my case, for example, let's take my camera. I have QSI 583. It's based on the codec 8300 chip that everyone knows about, and it takes at one by one binning, it takes around 20 seconds for the one image to download. But I usually take like a 5-minute exposure, or sometimes 10 minutes, and this 20 seconds doesn't matter. And this 20 seconds on my PC or on the Raspberry Pi, it's the same number. Maybe on the Raspberry Pi it's a little bit slower, but it's not that much slower than a regular PC.
Mm-hmm. Yeah, and I'm wondering, isn't USB 3 like, is it 5 gigabytes per second or something like that, or something?
It is, yeah, it's 5 gig.
Your hard drive can't do that. So.
Well, if you have SSD, then yes.
Oh yeah, if you have SSD, okay.
It's 5 gigabits per second, and I think the new one, the new generation 3.1, it's going to take that. 3.1 Gen 2 is going to take that to 10 gigabits per second.
Well, that'll be nice. And then, well, but then the camera manufacturers have to start introducing it.
Right.
I can see that being a lot more helpful though for planetary, anything that's demanding of frame rates.
Exactly.
That said, maybe it'll change the way we acquire. Although I can see the accumulation of data just being insane by using tons and tons of individual subs for deep sky astrophotography. But I don't know.
Absolutely.
Yeah, I mean it adds up in solar for me. So. Does the Eagle Hub not use USB 3. I do not know about the Eagle Hub.
Yeah, so the Eagle Hub is, you can consider it as a really high-end mini computer. It's provided by an Italian manufacturer. I cannot really pronounce their name, Primaluccia or something like that. Yeah. But I don't know its specifications. But it's a lot more powerful than Raspberry Pi 3 and a lot more expensive as well. But like, for example, the difference between getting a Raspberry Pi 3 today is that you can get it today with the complete astrophotography stack, like the complete thing. So you get the astrometry solver, you get the guiding, you get the capture, you get the scheduler, and you don't have to pay a single dime. Where if you get like Eagle 2 or any Windows box, actually, you're gonna have to buy all the software, not ASCII drivers. ASCII drivers are mostly free, but you're gonna have to like buy the other software on the top of that. But like today, this is why I say it doesn't really cost much, at least to explore this option, the single board computer option, because it's the barrier to entry is pretty low, and anyone who just had interest in electronics, or, and I think we all probably share something like that, being into the astrophotography hobby, it's pretty easy. Just go to Amazon, get a Raspberry Pi, and then we have instructions on how to like download an image or like build an image for your astrophotography setup. One of our Mac developers, Robert Lancaster, he said he might be able to join us later, and he actually developed a whole image for anybody to deploy on a Raspberry Pi without needing any technical knowledge.
Really?
Yeah.
So that makes it really easy.
Yeah, the barrier to entry is pretty low right now.
Huh.
I mean, I'm Adam, and
Yes.
you know, this is Tolga. I'm not a computer person. I'm a computer user. I'm not a programmer. And if you ask me my experience in computers, you know, I'm not that knowledgeable. Like, I can't do programming. I can play with, but I was able to pick up a Raspberry Pi and make it work. I mean, if I could do it, I think anybody could do it, because I'm not a computer guy. I'm just an average Joe, and it wasn't that hard. It took I took a little, but I mean, there's so much available information on the internet. You come up to a problem, you just do a search, and boom, you just find the solution. Yeah. And it was really simple. Yeah. It took me a couple hours to install the software, and it started working right off the bat. It was very simple.
Yeah, there is a massive user base for Raspberry Pi in general. So if you're having a non-astronomy issue, it's a simple Google click away.
I'll tell you what I found to be different. The image download time was not a problem, because I mean, once we're doing deep sky imaging, it doesn't. If it takes 15 seconds to download an image, who cares, right? Once you start if you have a 2-minute exposure, your download time is 15 seconds. It doesn't matter. The only thing that I did notice was things like plate solving took longer. Something that would solve in 1 second on a regular computer took about 8 seconds on the Raspberry. Would that be correct, Jasem?
Yeah, absolutely. I mean, if you're using the ARM Cortex CPU on the Raspberry Pi, they're no way as powerful as your desktop CPU. And all astrometry do is they do this like, big number crunching, and this sort of like star recognition algorithm that they have to do, and they have to sift through tons of indexes to locate to match the pattern of your image with the database. And so that takes a lot of RAM, it takes a lot of CPU power. But notwithstanding that, I heard reports from other users that sometimes the plate solving on their desktop actually takes longer, and it's not as reliable as when they do it on the Raspberry Pi. And this is not a hardware problem now. This is like a software optimization issue. So if you know how to optimize the solver to really intelligently find your solution in the sky, to narrow it by location, to do some tricks in the image itself to make it easier to solve, then you can cut that down time significantly. So it's not it's not always the hardware. Hardware always help us lazy programmers, of course, but sometimes you have to work hard and get the software to be competitive and work as well.
You said there was a complete suite of programs available in Image that you could install that would give you everything that you need in order to get up and running. Are any of these branded products, or are these all unbranded?
What do you mean by branded? Like
Maxim, Focus Max?
no, I mean the one I'm responsible for is called Ecos. So currently on the Raspberry Pi today, we're talking today, you can find the SkyX, so it's supported. You can find Ecos, that's supported, of course, and you can also find Sky Charts, or in French, Cartes de Style, and it's also supported. VHD2 is supported in the Raspberry Pi. I just uploaded a video just yesterday about using VHD2 in Stellarmate, so it's supported there. But MaximDL, no. Focus Max, no. These are exclusively Windows programs. Now, you can actually run it not on a Raspberry Pi, on other ARM boards, you can run that, but you need an x86, like with an Intel Atom processor or Celeron or something like that. You need an x86 system to install Windows 10 on it, and then install these programs on them.
What I found is that the cheaper stick PCs with Atom processors, they're actually worse than Raspberry Pi. The Raspberry Pi works better than the $99 stick PCs. But once you go to the mini PCs, obviously it's better because they have, 64-bit operating systems and things like that. But, small to small, Raspberry Pi wins.
Interesting.
Yeah, and I've been using it in my observatory for the last couple of years. Actually, just today I uploaded an image of a friend of mine who's using his Stellarmate to image the southern region. So he made a mosaics, 3x2 mosaic of the southern region with his Moravian CCD, and he had some spectacular early results in H alpha using a Raspberry Pi 3. So some people can get really, really good results with just using single board computers. If we're talking about maybe 4 years ago, you wouldn't see results. But if you go to Astrophotography today and you type in K-stars, for example, then you're gonna start to see some more images pop up of the capabilities that can be achieved with single board computers. I think they're the future. It's just a matter of time. We need these small incremental improvements in hardware, and as soon as we get the USB 3, more RAM, like 2 GB, 4 GB RAM, it's going to be a whole lot better and more accessible to even more use cases.
So I'm guessing there is no way to upgrade the actual RAM in them if you chose to hardware-wise, right?
No, unless you want to solder something in. I don't know.
That's actually what I was wondering, but not for the masses. Can you use multiple Pis to share processing load, one for imaging camera, another for scope tracking?
Absolutely. Right, that's a very smart question. So one of the key features of Indy, which is the communication protocol used, is that you can actually have it work in a distributed fashion. Ooh. So for example, you can have one Raspberry Pi just dedicated for the telescope, another one dedicated for the camera, and then they can be changed together. And as far as like the program that's using them, let's say K-Stars or whatever program using them, then they see it as just one server. They're talking to one server. So they can absolutely share the loads between multiple Raspberry Pis.
That's interesting. Yeah, because if you could build Raspberry Pis into each individual device, or I should say maybe the more difficult devices like the guide camera, then it would be an easy way to share the load. Although a couple years, I don't think you're going to need to share the load. I think they're going to be more than capable. It's just a matter of a few 18-month periods, right? As processing doubles.
And this is the same setup that is used in professional observatories. Just recently, I was working with Mount Monstic Observatory in Spain, and their Indy setup works like this by chaining multiple devices between the mount and the cameras and the weather system, the CCD chiller, etc. It's done like this, and they're all like chained together to one system for the client software to control at once.
Mm-hmm. How are they wired together? Are they wired together, I'm assuming?
Well, they're like, think of them, they're connected to the same router. So each one get their own IP address, and then you just communicate with each other.
Oh, that's really good. Huh. That's interesting. I can foresee, I don't know why I always think of this in my mind, but I could foresee like basically every light switch in your house having its own IP address. Basically every device in your house having its own IP address, so you just pick up your phone and turn it on and off. I think that's really...
That's the Internet of Things devices, yeah.
I really like so I used Raspberry Pi for a little bit. I'm not using it right now, but about a year ago, I was using it exclusively. And one of the best benefits I found is the weight. The thing weighs nothing. Literally, it weighs less than your guide camera. And you can stick it on the side of your telescope with like double-sided tape. And the power consumption, they use less than 1 amp at 5 volts. So they almost use no power. Yeah, so for field setup, they're excellent.
Mm-hmm.
Absolutely. You can even use like a power bank to keep them up and running.
Mm-hmm. How do most of your users view their sessions? Cell phone, iPad, or laptop? Does it depend on their routine?
Yes, yeah, exactly. It depends on what they want to do. So some users would use like VNC and directly use VNC to get into Raspberry Pi and see what's going on, or in Stellarmate. Like in my case, I use K-Stars and directly remotely control the Stellarmate, and I never use VNC actually to do anything. I just use K-Stars in remote mode to control everything, and it's all completely transparent to me. I just recently finished from developing a beta program for something called Ecos Live. So Ecos Live is like a real-time web application for phones and tablets, and it gives you the simplified web interface to control Ecos on the web. It's like your command and control center on the web to issue all your commands. So now we have a new interface added to the existing interfaces. So you have a rich desktop interface, and now you have like a web interface to do almost all the important functionality in Ecos. I've heard of people using VNC, but that actually is a rare occurrence. Most people would use the remote functionality within Ecos.
Cool. Yeah, I'm a fan of the web interfaces, particularly not so much when it comes to like just a camera or just a focuser, but when you're talking about the all-in-one acquisition, then yeah, give me a web interface, and I mean, basically, you don't even need internet if you're out in the middle of nowhere. You just log in via local network with your cell phone or iPad, and you've got it. I'm a fan of them in that case.
Yeah.
Yeah, a few people are saying they're using Nooks, which I actually use Nooks at work because they are just really small, and I look at them as good enough PCs for 99% of the stuff that most people are going to do. What I like about them is they're small to use at work. They're still a little bit large to mount on a PC. Now I know, or excuse me, on a telescope. And I know, yeah, they're much smaller than a lot of the other devices out there. But really, the idea of using something that's the size of a Raspberry Pi, kind of basically a palm-sized computer, rather than like something that I don't know. I think the Nook is 6 inches by 6 inches, or maybe 5.5 by 5.5. But smaller is better, particularly when it's riding on top, far away from your OTA. Excuse me, far away from your center of balance. What is a Nook? A Nook is an Intel mini PC.
Yeah, I just looked that up.
Yeah, Intel brand. And then they did a decent job. I think they start they sell ones, like you can buy them on sale for $99, but they really don't have a lot to them. Really low on RAM, really low on processing power. If you step up to like $199 and I think $249, or even maybe $299 for an i3, I'm actually not sure what the current prices are, but very nice. Mike's commenting on ASCOM, about 50% chance that the driver and any programs attached to it will hang or crash if the device is powered off or disconnected unexpectedly. Yeah, I've experienced that. Sorry for the silence as I read through the questions.
Are you seeing them in the chat? Because I'm not seeing the questions on the chat.
In the chat that's on our website.
Oh, okay. Let me.
Yeah, the one that, yeah. How rugged are the mini PCs? You know, they do have more industrial ones. I am inclined to say that they're not really designed for the environment we're putting them in, but they do a relatively good job. But that's the reason why I wouldn't buy a gaming laptop for astrophotography acquisition. I would buy a cheap laptop because it's going to get dewed on. Something could go wrong. The way to overcome issues is to save money in case you have to replace it. That'd be my. That said, computers are just in general are a little bit more rugged than we give them credit for. At least that's been my experience.
Someone on YouTube wants to know where they can get the Stellarmate.
Stellarmate.com. Go ahead, Jasem.
Yeah, yes, exactly. Just stellarmate.com.
Yeah, and we did have a previous session on it, so you get a good idea as to the basics of it, and his website's really detailed as well. Linda makes a good point that not having a keyboard or a screen means that whether it be a mini PC or Raspberry Pi, one fewer integrated item to break or go wrong. And I can vouch for that. because my C key on my acquisition laptop does not work. And it is very difficult to cut and paste a C in every time I need to use it. But I do not want to replace it. Not that I don't want to replace it, but I'm always afraid of replacing something that works, with the exception of the C key.
Yeah, this is why I said that the cheap price is an advantage, not because it costs less, because if you lose it, you don't feel as bad. You don't feel as, you know, devastated than like losing your Mac Pro or, you know, Dell laptop or whatever. If you lose it, you can just replace it easily.
Yes.
And here's another advantage. Put this onto the pro list. So what you do with these is that they run on a little SD card, and you make a copy of that SD card, and you stick it into another Raspberry. You just have a clone. There's no software installation, and you know, when you reinstall Windows, what do you have to do? You have to go get your software, you have to get your databases, install your camera drivers. No, you just make a copy of that little SD card, stick it into a new Raspberry Pi, and you're done.
Mm-hmm.
Like literally, it was just like as from yesterday.
Yep. Yeah, and that's why when Jasem said that they had a disk image of the Raspberry Pi, or an image of the Raspberry Pi, that's or an image of the software to go onto the Raspberry Pi. That's actually very attractive because if you have a laptop and you make a disk image, but your laptop breaks and you get a new laptop with new features, your disk image may not be 100% compatible. In the event of a Raspberry Pi, I'm going to assume that it's going to be almost 100% compatible because it's the same hardware every time.
Exactly.
That's why I'm afraid to buy a new laptop, because something is not going to work. And I actually have a new laptop and something doesn't work, so I use my old one. Mike Miller had a I remember this Kangaroo computer, which was probably just a cheaper mini PC, but they have come a long way in the last few years, and they're actually advancing fast. Glenn got an Azul Access Plus, hooked everything up, test run, everything was okay. Wouldn't get out of its own way when he actually used it. Yeah, laptop worked better than a stick PC. Yeah, the stick PCs are very underpowered. The stick PCs, a lot of them are really designed to be put into just a monitor to have a basic workstation. I know what we do isn't very demanding, but there's a lot of stuff going on, and you really don't want to be underpowered. You risk crashing. You risk a few different things. So,
I just want to give a shout out to Rob Lancaster, Robert Lancaster. He's a developer of K-Stars, and he's the man behind our Mac OS version. He's been working on it with other developers for the last year, and he's also an active developer in Andy. So he's been responsible for a great deal of the software you're using, and I guess this is mostly a hobby for all of us. You know, it's our passion: computing, computers, and astronomy. So it's really great when you develop open source software and you see all these people from the whole globe coming together to create better software.
mm-hmm.
So just thank you, Rob, for your contribution to open source.
Yes, agree. A big fan of open source, particularly in astronomy or any sort of hobby-based computing.
Exactly.
it saves everyone money if they're able to contribute what they know. They can contribute their know-how, and they're willing to do it for the good of basically the hobby. A different Rob is saying he wouldn't hold his breath on a much higher spec Pi. Pi Foundation wants to keep low cost of entry. They basically release the best spec over time at a given price point. And while I agree with that, I still am going to say yes, but in a couple of years, the same price point is going to have a lot better processing power. So we're constantly going to be improving and improving and improving. You can look at it like the processing power doubles every 1.8 months, or you could say the processing power cost drops by this amount every 18 months. Yeah, Rob has had success with it. So single Pi, of course, using a single Pi. SQL Astro is saying something interesting. Put plate solving on the cloud, or use something like astrometry.net to do the hardcore processing power, which would probably work, assuming you have internet where you are. I know that Sequence Generator Pro does that, but I do think a lot of us have chosen to have astrometry.net placed locally on our machines, just so we're not relying on internet just in case.
Right, yeah. I have it running on Stellarmate itself, and it's pretty fast.
Yeah. And as you mentioned earlier, optimize your settings on that.
Exactly, yeah, that's the key.
Yeah, that makes the biggest difference. I can go from a 60-second solve to a 5-second solve, all just based on tweaking the settings. Even a 2-second solve in some cases, but just make sure that you're
actually, regarding the solving, that there was an interesting bit about optimization that I'd like to share. In the prior versions for ECAS, the solver module would calculate the optimal field of view based on the CCD dimensions, the pixel size, and your focal length. And then it would pass this information to the solver so that it can speed up the process. Now, it turns out that some people will not have the exact focal length because they might have like spacers, or they might have I mean, not a focal reducer, because if you have a focal reducer and if you don't change your effective focal length, then you're doing something wrong. But then you have all these conditions about like a filter wheel in the middle. So just recently, what I did is I decided to completely get rid of the deterministic field of view and made it send the first time you solve an image, just for the first time, it would say, I don't know what the field of view is. And it would solve it. It would take longer, much longer the first time, but then it would exactly give you your field of view, which I call effective FOV. And this step would just, makes a big difference in the future when you make your solve request again.
Yeah.
So little optimizations along the way.
Yeah, I know that, let me think about this, what I call my paper image scale, the image scale that if I did the math on paper comes out to, I believe, 0.71, but when I actually hook all the gear up with my spacers and whatnot, I'm at like 0.78. So it's rarely comes up exactly how you expect it to when you do the math, and even if you get out your caliper and do all of that stuff. So that is the optimization that got me from 60-second solves to like 5- and 2-second solves. So just that little bit right there.
Right.
Also, some exposure time. And there's a lot of optimization you can do with plate solving. Yeah, some people are making an interesting comment that VNC eats up CPU. heavier duty than Windows Remote Desktop. Of course, Windows Remote Desktop, you have to have Windows to Windows systems. But on the other hand, of course, you do not have to have VNC running the whole entire time. You can open VNC, start your session, make sure everything's going, close VNC, and then log back in at the end of the night if you choose.
Well, on Stellarmate, we're using something called no VNC. So it's a server that acts like VNC, but only through a web interface. And so you go to like an address, a URL, and then you just control your desktop from there. So it's again, it's using WebSockets, so it's a lot easy on the resources than just a plain old VNC.
Interesting. No VNC, NOVNC?
No VNC, it's called, yeah.
That sounds interesting. Yeah, the Pi makes the Nook look like a giant. Rob Lancaster's using Ubuntu Mate on the Pi and on the Mac, on the laptop. So if you're using Pi and Mac, I guess that's the that is the remote viewing software.
Yeah, especially if you're using a tablet, then probably using something like Real VNC will give you better results than the web version.
Rob's saying that what he would like to improve right now about his Pi is that it's currently strapped to a scope with Velcro. So it looks like you need some sort of mounting hardware.
Yeah, that's the mounting part is excuse me, is not included actually with Stellarmate because it just uses a regular Raspberry Pi case, and at the price point where Stellarmate is right now, you cannot really put anything extra.
And machining mounting hardware is actually very expensive. I'm sorry for the silence as I try and run through what look like some increasingly complex questions.
Is this on YouTube or?
This is on the chat. Let me see if I can share this. Hold on. Let's see if this works for you. It might not because I'm logged in.
I can see the website questions or
The
chat.
Yeah. Yeah, this is Jurgen chain multiple indie servers on a local indie server. So when he has problems with the driver, he can start that specific indie server process again. There's one drawback: ECOS program disconnects, but it can be restarted quickly. But all it looks like, yeah, that was his comment question. I think just a comment.
Yeah, that's a comment. For the question initially asked about the problem with the menu disappearing, this issue was actually just fixed a few hours ago. So if you check the nightly builds, we have nightly builds and we have stable builds. So if you check the nightly builds in a few hours, then this problem should disappear.
Is RPI Odroid a suitable choice for a central hub like a Nook ICS to host imaging? And I can't say I'm familiar with that. And if you want visuals, can you remote into an RPI? What's an RPI?
It's Raspberry Pi.
Oh, duh. Was
Just
it
short
lowercase? Is that why? Yeah. I don't know.
So
Okay.
I'm not sure if I understood the question, but you can definitely use. I've used Odroid C2, Odroid XU4, you know, Banana Pi, BeagleBone. I've used all of them. And while Raspberry Pi is not the most powerful, and it doesn't have USB like 3, but so far today, it's one of the most reliable. Now, one contender that can maybe shake its place now, its dominance, is the Asus Tinker board. So the Asus Tinker board is a newcomer. Its operating system support is not as solid as Raspberry Pi. It's a bit sketchy right now, but hardware-wise, they're more powerful than Raspberry Pi hardware right now. I think next year, like maybe Q4 of 2018 or Q3, we might see another Raspberry Pi release, and if not, then we'll definitely see better single board computers released by their competitors, which hopefully would put more pressure on the Raspberry Pi Foundation to produce something. Yeah, Rob says here, Tinker board, somebody tried it, but had some issues.
Is there a way to output it to multiple monitors? And I don't, because his current routine is to use PhD2 on one monitor and capturing software on the other. I don't know.
I don't see why not. I use 3 monitors here, and I use all the windows all over the place.
Right. Yeah. Mike, yes, I can run remote. I can use my new laptop to remote desktop into my old one while it's connected to the mount, and that is how occasionally I get my C typed in there. Really hard when I'm trying to search for NGC anything. Yeah. Okay, I'm just trying to sort through the questions. A lot of them popped up. Looks like Rob Lancaster's doing a good job of answering a bunch of more specific stuff on in the chat as well.
Okay, so I saw a question. Does the Stellarmate work with Mandy and Gemini 2? And the answer is yes, it works.
The stream did not just crash. It should be still up, I believe. Yeah. There might be, I don't know if there's something on, there's an echo in the stream. I'm not hearing it on my end. I can quickly check one thing. It was when Jasem talked. Well, we'll see if it continues. If there was some sort of latency or something like it could cause that. If it continues, we can try and fix it. Any other further questions while we have Jasem here or Rob in the chat room? Yeah, maybe you're hearing my voice through his microphone. That's a possibility. I'll try and mute my microphone when he's talking. That said, if we don't have any further questions, then I will probably just thank Jasem for coming on. I'm going to thank Rob Rob Lancaster for popping into chat as well. Too bad we couldn't get you in the room. We should have tried this earlier. I want to double thank Jasem though, because Jasem, you live where?
Kuwait.
Kuwait, and it is like 4:30 or 5:30 a.m. there. Thank you for coming on.
Sure.
So thanks for your dedication as well. Although I guess I've said this before, we're astronomers, but we don't stay up late. We automate. That's funny though. But yeah, thank you all for coming. I will try and get a session posted sometime mid next week. Usually if I don't get it posted until later in the week, it just means we're going to do an open session. This week I was very late because I was camping and I had a great camping trip. Called for rain, 90% chance all 3 days, and it didn't even happen. I got rained on once for a few drizzles. So my week turned out well. And of course it ends nicely with an Astro Imaging channel session. So thanks again, Jasem. Thank you all for watching. Good night, and we'll see you next week.
Bye.